Hi guys, welcome to your second video here. This one is continuing the Earth's resources themes, and we're going to be looking at potable water. Okay, potable water. Potable water, the first thing that we need to know about that is, firstly, what does potable water mean? I'm really aware that I've said potable water about 3 times already. But anyway, all that potable water is water that is safe to drink. So, what potentially could be in water that would make it not safe? Well, that could be bacteria, and that could also be salts. So let's have a little bit of a history lesson to start with. When the Earth was formed, obviously it was really hot, and it was the temperature was way above the boiling point of water. So what we found, what we will have been is lots and lots of water vapour in the air. As the Earth cooled down, then what happened was the clouds began to condense and the water started to fall on the Earth as rain. And it will have found its way into kind of rivers and gullies and basins and formed the lakes and rivers and seas and things that we've got now. And this is how the water, the seas and things formed. So when the water's up here, it's fairly pure. It's fairly pure water, but it is percolated through time. It's percolated through rocks, which are permeable, and inside the rocks there were salts that were solid, but they've been dissolved by the water as they've percolated through, and that has led to the seas and things that we know today, which are salty. The main salt in there is sodium chloride, and I'm going to represent the sodium chloride with some horrible green dots like this. So if we take a big gulp of salty water, I think you probably know what happens. It makes you sick. Actually, you can't drink it and your body rejects it, so you would vomit that out. So I'm just going to label that sodium chloride. Sodium chloride. Now, you will remember sodium chloride from one of the earlier topics that we discussed, ionic bonding. It is sodium, Na+, and chloride, which is Cl-, which obviously differs from chlorine because it has gained an electron in order to form that ion. So what can we do about this? Well, there are 2 ways of getting clean, potable water from salty water or saline solution, as you may also hear it, and that is through, firstly, distillation. So if I take a big round bottom flask there, and I connect it to an elbow joint like that, I can put a thermometer in the top so I know what the temperature is, and I can connect that to a special piece of equipment called a condenser, and this one, which you should recognise from when I actually did the practical with you, is a Liebig condenser. And then on the end we've just got a little glass tube that funnels the water down. Inside this there is a jacket of water. So we've got water in there and we've got water out there, and it's cool water, so obviously that helps with the cooling down process. Then obviously I'm not just going to let this run onto the floor or the bench, so I need something to collect it in. And there's my beaker. You'll notice when I'm drawing my diagrams I'd use simple lines. It's a lot easier than trying to do some kind of artistic impression, and it's completely unnecessary. However, you should all be able to draw a kind of easy, simple diagram like that, and if you struggle with it, use a ruler, and that's it. It's not there to be particularly difficult. So I've got in my flask, my round bottom flask, I've got some salty water, which again I'm going to put some green bits in there to make sure that we are well aware of what is in that water. And also I'm just going to close the top of that up because I don't want my steam to escape. Right, then all I need to do is apply heat. Right, so what will the heat do? Well, obviously the heat is going to boil the water. Okay, and we'll get some nice curls of steam, nice clouds of steam coming off here. So we are going to apply enough heat, put enough heat energy in there that the amount of energy that each particle has is greater than the force that holds it together. Okay, and then once that happens, we'll start to get particles boiling off. You should remember this from physics topic, in fact, okay, called changes of state. So here we'll get boiling or evaporation. Okay, you should be able to tell me what temperature is that is in my thermometer. Okay, and that should be 100 degrees C, because obviously that is the boiling point of water. Okay, and the steam is boiled water, okay, or water vapour. And the water vapour will run up here and it will come out into the condenser. Okay, where around about this point here, we'll start to get it forming into liquid water. Okay, and it will run down here, down my glass tube, and fall into my beaker at the end, so I can label this pure or distilled, or in fact potable water. Okay, so theoretically that should be safe to drink, but obviously if you're in a lab, don't drink it, because you don't know what's been in that beaker or how well it's been cleaned beforehand. Okay, so the other part of this is around about here that I need to label, okay, where the water will condense. Okay, we can also call this water that's falling down here, condensate. Okay, and that just means a liquid that has been condensed. Okay, we don't really need to worry about that in terms of your vocabulary for GCSE. It's just sometimes it might pop up in the exam, so it's best just that you've heard it before. So that is our first method of desalinating water. It's worth noting that heat here takes a lot of energy. Okay, so I'm going to represent the energy with lightning because that's what I always think about, energy. Okay, so it takes quite a lot of energy. If we do this on a large scale, it's going to cost a lot of money. Okay, there's going to be environmental impacts as well, because obviously when we produce energy, a lot of the time when we're producing energy, we're burning fossil fuels, particularly in this country. In places like Africa, it's too expensive for them to do that, but we'll come back to that a bit later on. So that's our first method of desalinating water. Okay, I'm going to put a little label of distillation, okay, around that part there. I'm going to put desalination. You'll see this saline part from saline solution, okay, that a saline solution is obviously one of water and salt. So desalination just means we're taking the salt, S-A-L, salt, salination, okay, desalination is just taking the salt out. Okay, and so our second method here is a different one, okay, and what we have is a tank of water, like this. Okay, and in the middle we've got something called a semi-permeable membrane, which you should remember semi-permeable. Now, you should remember that from your biology lessons. Okay, so semi-permeable, semi obviously means half or partial. Permeable means that it can permeate. Permeate means just that stuff can pass through it. So semi-permeable just means that some things can pass through it, but not others. Okay, and a membrane is just like a thin layer or divider. Okay, so again, we've got salty water on one side, like this. And on the other side, we've got pure water. Okay, and what happens is we apply a pressure to one side and the water will pass through, but the salt will not. Okay, so I have water passing through there, okay, like this, but not the salt. Okay, and that is how this process works. Okay, you should also, this is quite a biological technique. It's quite recently discovered as well, or recently put in place. It's called reverse osmosis. Okay, reverse osmosis. Okay, and we're just putting pressure, okay, onto this side, and that will push the water but not the salt through. Okay. So again, this putting the pressure on, in fact, takes quite a lot of energy. And again, as we've discussed, energy costs a lot of money, and it also leads to some fairly negative impacts to the environment. Okay, so the negative impacts here are a little sad face. Okay, so it's costs money, you need lots of energy, okay, and costs money. So the wealthy countries, places like Saudi Arabia, UAE, they can afford either of these two desalination techniques, but the places like Africa, where we're also under quite a lot of water pressure, cannot afford that amount of water. That amount of money. So it means that these desalination techniques are not really available to them. This one here, the reverse osmosis, is becoming cheaper. Okay, so now I've given you the background. What I would like you to do is complete the questions on both potable water and desalination on your in your mastery booklet. Okay, so don't forget, smash that like button, don't forget to subscribe and get that notification bell dinging.